Question letter B, just like question letter A, is just going to be a series of algebraic steps. We just have to get rid of everything that we can, focus on the exponential, and use logs to help us do the messy parts. Now, before I do anything with log, I always want to get rid of whatever's not directly attached to the exponential. Remember, usually it's like the initial value that we want to get rid of first. The letter B doesn't have an initial value in the way, but it does have this plus 4, which I'm not used to seeing, but I can definitely tell is in the way. So the first step that I'll engage in is to get rid of that plus 4. That way the problem looks normal, looks the way we expect it to. 2.394 to the power of 2x minus 3 equals, if I subtract the 4 to the other side, 99. So now I know that I have something that looks much more exponential in nature, and now it's going to look more familiar. I have something to the power of x. Granted, the x is a bit crowded with other things, but no big deal. I have something to the power of x equals a number. Now I know I can do my log process. We'll write the word log on both sides. Of course, if you're bypassing some of these steps at this point because you already know where this is all going, that's great. The purpose of writing log on both sides is to bring down the exponent, even though, weirdly enough, it seems as though x is not the only thing coming down. When I bring the exponent down to the front, it looks like the 2 and the minus 3 are also coming along for the ride, but that's no big deal. Anytime that happens, just throw it in parentheses to show that it all got brought down together. Then, of course, we recopy everything else that did not change, and we go from there. If I want to get x by itself, and again, x is kind of a package deal here with the 2x minus 3. I'll deal with that in a second. But if I want to get this thing, this exponent by itself, I got to get rid of the log part. It's multiplying, therefore I'll divide it to the other side. And divide it to the other side as well. That cancels the log from the left-hand side, which is good. Now again, I'll have to deal with the fact that it's not perfect. It's not exactly like I'm done with the problem. I still have 2x minus 3, unfinished business, if you will. But I'll write this so we can see it here. 2x minus 3, oops. Get my scratch paper lined up. 2x minus 3 equals, now a calculator can do the rest for me. Log of 99 divided by log of 2.394 would give us 5.264. 5.264, but that's not my answer because x isn't by itself. The good news is x is not hard to get by itself. Now it's just basic algebra. We can add the 3 to both sides, so 2x would be equal to 8.264, and then I can divide both sides by 2, so x would be 4.132. Now, the true moment of checking comes from plugging that back in to the original equation. And you can do this in a variety of ways. Again, you can check the answer key, you can use a calculator, lots of different choices, but we're not expecting this to be the nicest, easiest process. We just want to prove that it works. 2 times 4.132 minus 3 plus 4 afterwards equals something very close to 103. Again, it's not perfect because I rounded my decimal, but it's really, really close. So that's how you know our answer makes sense. These were complicated examples in questions 6A and B. These are among the hardest types of equations that you would solve with logs. These are definitely not typical of Algebra 2 questions. These are more math analysis in nature. So if you did these and followed along, that's awesome. And if you didn't, it's not worth panicking about. You'll see plenty more opportunities to practice next year. You'll have lots more chances to really wrap your head around this. So this is like icing on the cake. If you can do this, this is awesome. And if you can't, it's no big deal. Don't stress yourself out about them.